So we will start this session on transportation, surface, water, and air transportation sensors. And I will be the session chair. My name is Rolland Vida. I'm from the Budapest University of Technology and Economics, Hungary. I'm also the vice president of the Census Council for conferences. So we are organizing this specific conference as well. And so I will give the invited talk now, and then we will have 3 other talks following this one. So I will talk about sensor-based applications and services in smart city transportation. So this talk will be focused on smart cities. And so I will not enter that much into the technical details of specific sensor devices. It will be more like on the ways to deploy and organize all these sensor related services and applications, also kind of economic aspects, human aspects. So I guess you all are familiar with smart cities. What a smart city is, actually there is no standard definition that is accepted by everyone, but let's say in short that a smart city will be a city which is sustainable, energy efficient, with active participation of the citizens that are living there, so the communities, economically self-sustainable, including all kinds of innovative solutions. And obviously the final goal will be to have a good quality of life. What is important on the first line, the first 2 lines I left to the end, that it builds on an integrated digital sensing, communication, and data management infrastructure. So meaning that you should not deploy specific infrastructures for specific services, but everything should be integrated. The same sensors should be used for different kinds of applications and services if possible. And also one very important thing is to have adaptivity. So adaptive services that are obviously based on real-time sensing data. Okay, so and I will talk about transportation. So this is a very important part of smart cities. So to have intelligent transportation systems, we all know, especially being in India, that we have all these problems of too many people, too many cars, too many traffic jams, very inefficient transportation of people and goods. So the question is, how can we improve efficiency? And the answer would be to make the services, the city operation, adaptive as much as we can, based on current traffic conditions, for example, not just based on past data. And the finer is the scale, time scale at which we can provide the activity, the smarter the city will be. So I will propose some kind of adaptive services, and I must to make a disclaimer. Yesterday, so it is my first time in India. Yesterday, I spent my day visiting the city in Hyderabad, and I faced how different the transportation and the traffic conditions are here. So I don't know if all of these things that I will present are directly applicable now with India. Probably, I mean, you should take into account the local characteristics for this. Anyhow, so some examples of adaptivity. So adaptive traffic lights, for example. Okay, so here in Hyderabad, you do not have traffic lights at each intersection, or they do not operate exactly in the same way as we see them in Hungary. So what would be here the issue is that you have a green light cycle, and to adapt that green light cycle to the current traffic. So basically how this is done is that they know how much traffic comes to the intersection from one direction to from the other from past data. And then they will set how long the red light or the green light should be for one specific lane based on this past data. Now the thing is, the smarter thing would be to be adaptive and to do it based on current data. What are we currently measuring? So how many cars are waiting in the specific lanes? And if we want to be smarter even, how many people are sitting on those cars, okay? Because you might have 5 cars, but just 1 people sitting in each car on one side, and the other, you have just 2 cars, but 10 people in it. So that should have priority. How can you have that data? So you have all kinds of sensors. You might have sensors on the road surface, that might be magnetic sensors, inductive loops, whatever, different solutions. You might have infrared sensors deployed in all kinds of roadside units. You might have image sensors, okay, so in cameras that are deployed in intersections. And you have more and more smart cars. Smart cars have lots of sensors. For example, they know how many people are sitting in the car because there are weight sensors in the seats. And they can communicate, okay, so you can gather all this data, and obviously you need communication. So communication is really important. Communication between sensors and traffic lights, between sensors and other sensors, between the traffic lights themselves. Basically, you have a local optimization problem that you want to solve in a given intersection, but you have to take into account also the global picture that there's a next intersection that is coming, so then the traffic should be regulated so that you can ensure this green wave that people should not wait at each traffic light. Okay, so you have to do measurements, and then you just have to do something with that measured data. So the question is how often you should measure, how often you should send the data, what kind of radio technology should be used, because you want this to be done in an energy efficient and a reliable way. Okay, so you need kind of a traffic counting, so to count how many cars are going to a given lane per time interval. But you can see that the same sensing technology can be used for other purposes as well. For example, for parking detection. So you will have basically the same sensing problem that should be solved. Just you have a sensor that is embedded in the road, and you need to detect when a given car is above that specific sensor. So that could be any kind of sensor, magnetic, optical, radar, whatever. It's the same problem that you solve. However, depending on your application, you might have very different needs. So, for example, a parking sensor needs less frequent measurements. Okay, so you don't have to measure all the time the car is still there or not. So it's enough to do 1 measurement per minute, for example. Okay, but for the traffic counting, obviously, you need to do much frequent measurements. Then the communication needs. So for the traffic counting, you need to send that data quite often if you want to have real-time data that is taken into account by the green light. Okay, for parking, basically, you just have to send the message when the status of the parking slot changes, when it changes from free to occupied from free. So basically, you send out 10, 20 messages per day, okay? So that's not that much. It's completely different. And also what kind of radio technology you use for this specific kind of application is again very different. So for example, for parking, you could use LoRa, which is a technology that provides communication at very large distances. So your LoRa base station can be at 4 or 5 kilometers away from you. But you can do that communication only very rarely and with not much amount of data. Compared to this, for example, if you would like to, so LoRa is good for parking, because it's exactly this what you propose, but not for traffic counting. On the other hand, if you deploy, for example, Wi-Fi is completely the opposite. So it would be good for counting, but not for parking. I mean, Wi-Fi, the distances will be much lower, so you will need to deploy an access point in each street, basically, that will communicate with all the sensors, and that's quite expensive. So basically, if you have this road here, and you can deploy two sensors, which are the similar sensors, but this monitors this parking slot, this monitors the traffic that goes on this lane. So they do the same sensing, but they operate completely differently, and they should have different radios and so on. Okay, talking about parking and adaptivity. So that goes to the economic aspects as well. So, okay, you deploy parking sensors, but how can that be used in a more efficient way? Okay, one thing is that you just monitor the occupancy of the parking slots, and you know in advance where are the empty slots in the city. So that's the initial purpose of sensing here. But how could you use that sensing data to make the entire parking system more efficient? For example, by adapting the price. Okay, so here's an example from San Francisco. They deployed this solution called SF4, in which they said that, okay, we will increase the price of the parking in areas where there are no more slots. So the occupancy is really quite high, about 80%, 90%. You will increase the price so that people should not park there, or they should pay quite much if they want to park there. But in other streets where the occupancy is very low, you decrease the price, providing an incentive for people to go there. Okay, so the idea would be to balance a bit the occupancy of all the roads. Okay, so you try to be adaptive. What they did is that they changed the prices only after 30 days. So that's not very real time, let's say. So you could do it much more adaptive by changing the price. I mean, even if not in real time, but I mean, changing it in real time, that's a problem, because I mean, you park your car thinking that it will cost you $1, and then you leave the car there, and when you return after an hour, it turns out that it was $5. Okay, so you will not be happy with this, but still, some final time scale would be nicer. Okay, how can you make the parking sensors even smarter? So what you do, traditional parking sensors just monitor the parking space occupancy, whether there is a car parked there or not. And what they do is that they just send this data to the cloud, where you have an application running which has a database, a map with the different streets and with the available parking slots. But they do not verify the parking rights, do not communicate with the cars, do not communicate with the driver. So the parking sensor just sends the data, and this will appear on your map of parking spaces. So, but there are lots of other questions that you could answer. So, for example, how is payment handled? So, did you pay for your parking? So, basically, the sensor, what could do is to alert directly the parking attendants. Parking attendants, what they do is they just scroll the different streets, and so yeah, from time to time, and they verify whether the guy paid or not. So they check the plate numbers and check in their system whether there's an ongoing payment or not. But they're not alerted by the sensor. They do not know where to check. Okay, so there's someone who occupied these parking slots. They will not get any alert. So this could be done actually. Or even smarter, it could be that the sensor communicates with the car. Why not communicating directly with the car? And if the car owner registers his credit card, when I'm parking, so after the car is parked, then the parking sensor can communicate with my car, so the car identifies itself, and then you can handle the payment directly. So it's kind of like Uber, how it operates, that you register a credit card and then you don't care anymore about the payment, right? So you just get in the car, get off the car, the payment is taken from your car. So that could be done in the same way with parking. Next thing, are you entitled to occupy a dedicated slot? So there are general purpose parking slots, but there are also dedicated parking slots. For example, for electric charging, for taxis, for car sharing. Okay, so you park there your car. Okay, the sensor detects that there's a car parked, but are you allowed to park there? Again, if the sensor can communicate with the car, it can get all kinds of information from the car, whether it is an electric car or not, whether it is a taxi or not, and so on. And if not, it can send an alert to the parking attendant that it should come there and track it. Also, so then this is communication with the sensor and the car. But sometimes it's not the car that should be identified, but it's the driver that should be identified, because it's a dedicated space for the driver. For example, for disabled people. Okay, in case of disabled people, they have this identification card that says, okay, I can park here in whichever car I'm in. Okay, so you just put this in the windshield. So in this case, your sensor could communicate with this card and then say whether this is okay or not, you're parking. But then sometimes, I mean, sensors cannot really solve the problem and are not the right solution. So the question is it allowed to park at all at a given place where you stop your car? So for example, next to a fire hydrant. In many cities, countries, this is not allowed by law. Or on the sidewalk, on bike lanes, on private driveways in front of someone's house, you should not park. How can you verify that a car is parked there? So you will not use sensors, because you cannot embed sensors everywhere on the sidewalk or in front of the houses. So I mean, this will probably not be solvable by traditional sensing technology. Maybe if you have cameras, that could be a solution. But also, so to track these things, you might use the human sensor. So in some countries, some cities, they are experiencing this, that people are asked to report parking violations. So this is an article from New York City. If you walk around in the city and you see a car that is parked on the sidewalk or on a private pathway, whatever, or on a bike lane, you can make an alert, okay, and then they will check. Okay, so this picture, by the way, is from Hungary. So it's a famous Hungarian actor that had this habit to park his car, his sports car, in front of the coffee shop that he liked to go there, and so people were very upset how he allows himself to do this. Okay, and they can report him. Speaking about private driveways, so basically there are solutions that the homeowner could rent out his own private driveway if he doesn't use it, so letting others to park. So there are these solutions like Just Park or Park on My Drive or others. So in this case, for example, it might be interesting for yourself to install one sensor that is embedded in your driveway, or one or two sensors, if you want to get some data and see whether someone occupies your spot or not. But otherwise, the city should not deploy parking sensors in front of the houses. Okay. Other adaptivity, public transportation schedules could be also adapted. Currently, what happens is that these are again based on past historic data. So you have different schedules for morning, afternoon, weekdays, weekends, public holidays, school holidays, whatever. But it would be good to adapt to the current conditions, because the current condition might be very different. One Monday morning might be very different from the other Monday morning because of strikes, road closures, whatever, marathons, public events, COVID, for example. So you should be able to be adapted. So these articles are in Hungarian. Sorry, but I will explain. This is a bad example of what was done in Budapest during the COVID period. So when the COVID came out, so the government said, okay, you should stay at home. That's one measure. The second measure, if you have to go, then you should keep distance from the others, okay, social distancing. So they said, okay, the metro, we should adapt to this new situation. They said, if there will be less people traveling, people stay at home, okay, let's have less metros, okay, so let's have a lighter schedule. And what they did, okay, they said, okay, when do we have a solution when people do not travel that much? Okay, that's a Saturday. Okay, so let's change. So let's use the usual Saturday schedule for each weekday. Okay, but that was not a good solution, because it turned out that on Saturday, so not many people could stay at home. There were lots of people who had to go to work still, and in the morning there were very large crowds waiting for the metro, and the metro did not come each 5 minutes, just each 15 minutes, and there were really large crowd in the metro. Okay. So this news header says that, okay, the local transportation company changed the schedule starting from this Monday, and then they realized that it's not good. And one day after, they said, okay, we change again, and they changed for the school public holiday. Okay, so they had different patterns from the past. One pattern was Saturday, one of the pattern was school holiday. They said, okay, let's choose between these, but these were not based on really current data that are coming from the sensors that are measuring the size of the crowd that is waiting there. Okay, yeah, so here's another example with adaptive transit scheduling for heat waves. So that's from the US, when there's a large heat waves in Arizona. I think it was implemented in some cities, so they increased the frequency of the buses so that people do not have to wait that much in the stations. Okay, this is about HOV lanes. So HOV comes from high occupancy vehicles. Okay, so the idea here is that to have separate lanes for those people who have more passengers in the car. So this is an incentive to do carpooling, and you see here these special lanes that can be used. So there's no traffic jam there. So this is an incentive to take your neighbor as well to the city. So obviously it has a lot of advantages. So less car, less pollution, and so on. But it has also drawbacks. If it's scarcely populated, then the rest of the lanes will be even more crowded, and you will have even larger traffic jam, even more pollution. So people try to fool the system. They had all kinds of solutions, like inflated doors that are put next to the driver. Then the police can use cameras, or heat cameras to detect whether that's a real person sitting next to you or not, so on. But I mean, there are things that you cannot measure with sensors, okay? So people are ingenious minds and they can fool the system no matter what kind of sensors you install. So for example, there was this issue of HOV jockeys in Indonesia. HOV jockeys are people who just sit next to you because then you can use the HOV lanes. So you pay them $1 or $2 and they travel with you to the other end of the city, and then they get off and then travel back with someone else. Okay, so this is obviously will not result in the result that we expected to have less cars, because I mean this is fooling the system. So there are solutions to do these attacks. So anyhow, you cannot enforce something in certain cases by the sensor technologies. So let's make it adaptive. So for example, everyone could use the HOV lanes, but should give priority when a real HOV car comes, then they should let him pass. Did we see some systems before like this? Yes, for police, firefighters, ambulances, you should give way when you hear someone coming behind you. Okay, you hear the sirens, you see the lights, so you will give way. So you could do the same with full cars. Okay, HOV cars. Obviously, you should not have sirens for each HOV car. That would be a nightmare. Although in what we hear in Hyderabad, that you hear the horning of each car all the time, so you can get used to that. But I mean, cars are smart; they can communicate and they can alert the other drivers that someone is behind you. So you should let him. So there's a full car behind you. If you do not have any passenger, you should let him pass. Okay. The question is whether people will do it or not. That's another question. Okay. When you will have self-driving cars, the self-driving car will do that. Okay. So that's it basically. So the conclusion is that adaptive services and applications are a very important part of a smart city. For that, for adaptivity, you need all kinds of real-time sensor data that should be done in a way to take into account what kind of technology you're using, what kind of radio to be energy efficient, reliable, and so on. But you cannot deploy sensors everywhere. So usually cities have limited financial resources as well. So you cannot solve all the problems with sensors. So as I said, human ingenuity and also selfishness, sometimes it's really hard to beat. So the solution is to educate people not to be so selfish, because at the end, if they are doing for the public good, the end result will be good for them as well. Okay, and so that was my talk. Thank you. So if you have questions, yeah, Dan.
I have a couple of questions related to humans. And one is, do you think that you have to track pedestrians to have a smart city work?
That's quite important to track pedestrians. Obviously, I mean, tracking when you're taking into account privacy, so tracking them in a anonymously way. But I mean, cities usually do not have this information about the flow of people in the city. They have an information about the flow of cars, but no information about the flow of city. That would be very, very useful, I guess.
My question, so a car hits a pedestrian, how does the smart city react in that case? Does it have to know that there's a pedestrian body on the roadway? Does it keep making the car try to drive over the pedestrian?
You mean that the driver who hit the pedestrian should stop and help, okay, and the alert should be sent. I mean,
yeah, some other than normal reaction needs to happen because there's no pedestrian lying in the road.
yeah, I mean, it's kind of what kind of alert could be sent around to the other cars approaching that area that pay attention, there was an accident here, so the accident should be detected, but I think that it should not be that, so, I mean. It's difficult how you track the pedestrian if you want to track him individually, and I mean, you can just see that he stopped walking, but why did he stop walking? Because he was hit by a car, or he just stopped because he's on the walkway somewhere. That's a difficult thing, so.
And then the other question, I know a big problem in San Francisco is an accident will happen where you get gridlock and the system doesn't know how to untangle, and it gets in the way of emergency vehicles trying to respond.
Yeah.
Again, that's a human car issue, not necessarily a car issue.
Yeah.
And can you eliminate humans entirely from the thinking of the smart city?
I mean, we are going towards this direction with the self-driving cars as well. Okay, so I mean, the human selfishness will disappear with the self-driving cars, right? So there is something going to this direction, but on the other hand, the goal of the smart city is to be a good place for humans. So it should not be a technological showcase or whatever. It should be a place where people like to live. So you should not eliminate them in this sense of controlling what happens to them. Any other question? Okay, if not, then thanks. So we should go through the report.